Okay, this is my concept map, and at the end I will zoom in so that you can read all the little links here. Okay, so here we have the elements, and I connected them with these little orange dots. We have sulfur, sodium, calcium, iron, phosphorus, potassium, oxygen, nitrogen, hydrogen, and carbon. And of course, carbon is the basis for organic chemistry. And down here we have saturated fats and unsaturated fats. And they connect to carbon because saturated fats have no double or triple carbon to carbon bonds, while unsaturated fats have one or more double or triple carbon to carbon bonds. And then we move down to cohesion, which means that the same molecules cling to each other, which for unsaturated fats we have carbon carbon clinging together. And then adhesion is the opposite of cohesion, where two or opposite of cohesion and different molecules cling to each other. And if we go back to carbon, we have carboxyl, which is composed of carbon, and then down to carbonyl, which is also composed of carbon. And from carbonyl, we have ketone, which is placed into a carbonyl molecule, and then aldehyde, which contains contains a carbonyl group. Back up to carboxyl, we go to carboxylic acid, and carboxylic acid is composed of a carboxyl group. From carboxylic acid, we can go up to acid because it's an acid, and an acid can donate an H plus ion, and an acid, the opposite of an acid is a base, and with an acid and base you can find pH levels, and an amino is a base. Back to carboxylic acid, we can go to amino acids, and amino acids are made from carboxylic acids. Then moving down to fatty acids from amino acids, I connected these because both of these can be used for energy. From fatty acids to phospholipids, phospholipids are composed of fatty acids. From phospholipids down to lipids, both of these are used for the biological membrane. And then lipid down to glycerol. Glycerol is the structural component of lipid. Back up to amino acid, we can travel to proteins. Proteins are composed of amino acids, and then from proteins to glycoproteins, and glycoproteins contain proteins. Okay, back over on the elements. So for my elements, I made like how you would see it on the periodic table. So we have the atomic number, which you can see right here for iron, and then the atomic weight, which is about 55 grams per mole. So from the atomic weight, I moved to grams and moles because you measure the atomic weight in grams per mole. And then I connected moles to liters, and then connected both into molarity because you measure molarity with moles per liter. I connected a mole to Avogadro's number because 1 mole is equal to 6.022 times 10 to the 23rd power. And here I connected liter to meter because meter is the basic unit of measurement. And then a millimeter is 10 to the negative 3 meter. We can come back up here to the elements. Sulfur. I can't pronounce this very well, but I'll do my best. Sulfhydryl consists of sulfur atoms, so I connected those. And then we have oxygen, and then we can go to phosphate. Phosphate is bonded to 4 oxygen atoms. And then hydroxyl here, I put it between the hydrogen and the oxygen atoms because hydroxyl contains both hydrogen and oxygen. And then moving from hydroxyl, we can go to alcohol because alcohol is obtained by hydroxyl. Here we go to nitrogen. Amine contains nitrogen. Then from nitrogen, we can go to nucleotides. And nucleotides are organic nitrogen base. And then we have nucleic acid, which consists of chains of nucleotides. And then nucleosides and nucleotides are both used in DNA and RNA. And then we went from nucleotides to sugar, and nucleotides are composed of sugar molecules. And then we have monosaccharides and polysaccharides connected to sugar. Monosaccharide, of course, is the simplest form of sugar. Polysaccharide is the linear branched form of sugar. And then from sugar, we go to carbohydrate. Carbohydrate and sugar, same thing with formula CH2O. And then from carbohydrate to glycolipid with the carbohydrate chain. Moving down back to the elements, we have hydrogen. I connected hydrogen with electronegativity and hydrogen bonding. Hydrogen bonding can take place when a hydrogen is bonded to a nitrogen, oxygen, or fluorine atom, and when it is bonded to another nitrogen, oxygen, or fluorine atom, it can make hydrogen bonding because nitrogen, oxygen, and fluorine are very electronegative. From hydrogen bonding, we can go to the hydrogen bond network of water. These shared electrons can attribute to the unique physical and chemical composition of water, and that can move us to water. I connected water to molecular weight because water is a molecule, and the approximate molecular weight is 18 grams per mole. Water can have a water isotope, and we can go from water isotope to radioactive isotope because they're both isotopes. And then radioactive isotope's half-life because a radioactive isotope is reactive, and the time that it takes for the radioactive isotope to reach half of its original volume is what a half-life is, or what a half-life is. Back up to water, we have hydrophobic interactions, and hydrophobic means it's like scared of water, so it does everything it can to move away from water. And so from hydrophobic interactions to methyl is hydrophobic. And then methyl to isomer. Methyl is related to methane, and methane, did I say isomer? Methyl to isomer. And methane is related to methyl, and methane is an isomer. Moving back down to water again. Water is a polar covalent bond, which is a bond where the electrons are not shared equally. And then I connected all the different bonds together because they can be related. Directly from polar covalent bond, we have double covalent bond and triple covalent bond, which is basically just the number of bonds connecting the molecules together. That's the only thing that changes here. We go from polar covalent bond to non-polar covalent bond. That's where the electrons are shared equally. That's the difference between non-polar and polar. And then polar covalent bond to ionic bond. Ionic bond is composed of opposite charged ions. All right. Back to hydrogen. We can go from hydrogen to the hydrogen ion. And hydrogen ion is formed from the removal of an electron from hydrogen. Hydrogen ion is an anion or a cation. And then I moved from cation and anion to chloride, and chloride is negative, so it's an anion. and chloride is also a salt. So I went from chloride to salt here. Back at the hydrogen ion, I went to hydronium ion, and the hydronium ion, it comes from the hydrogen ion in water. That's the only time that a hydronium ion can form, is when the hydrogen ion is in water. I think the only thing that I haven't covered is down here. So back to the elements. We move down to an atom. An element is made up of atoms. And over here I connected Dalton to atom because Dalton is known for his atomic theory and saying that no atom can be created nor destroyed. From the atom, I have proton, neutron, and electron. I connected the proton and neutron to the nucleus of atom, because the proton and neutron are both found in the nucleus of an atom. And then the electron is on the outer side part of the atom, and they're in the rings. We have valence electrons, which the valence electrons are the electrons that are on the very outside of the atom. And these atoms, or electrons, are either going to be the electron acceptor, or the electron that is accepted, and the electron that is donated. So from these, we have our redox reactions, and that'll happen. So if you have an atom that has one valence electron, that's going to be an electron donator, because it wants to have a full electron orbital. So if it loses one, the next one down is going to be full, and it's going to be happy. But if you have an almost full orbital, it's going to want to accept one to make it either full or almost full. I think that's it. So I will bring my poster closer to the camera, and if I can, I will attach a picture of it at the end of the video so that you can see it in a non-mirror way, and might be a little easier to read. So here I have my elements, and I have connected them with orange lines. And here we have carbon, which is the organic chemistry element, and then we have all of our other ones, which are in the inorganic chemistry, and I connected those with the yellow line. Down here we have the atom, parts of the atom, Dalton, and we go to redox, and we can go back up here to carbon. We can go to all of our groups, and we'll go down, and we can come back up to catch the acid and bases. There we go. And the last one for carbon is down here with the unsaturated fats, saturated fats. And here for sulfur, we have our sulfhydryl. And then we have our few with the atoms are phosphate, alcohol, and hydroxyl. And then we have our amine with the nitrogen. We can move to, let's see here, hydrogen, with our hydrogen bonding, and all of this. And I'll move so you can see the rest of the bonds and the isomer with the methyl. Alright. And moving back this way so we can get the nitrogen connected with the nucleotides. And I think that's it. Thank you very much.